Okay, so this is the second video in the monohybrid crosses, and you're going to stop this video when I tell you. So I have two people. They both got brown eyes, okay, but they are both heterozygous for eye color. Heterozygous. That means they have inherited two different alleles, one from each parent. This person, their genotype is big B, little b. They're going to have children with this person whose genotype is also big B, big B, little b. Okay? What are the chances of their offspring, their children, what's the chance of them having a blue-eyed baby? I want you to stop the video now, work through this, and then turn it back on and see if you got it right. Okay, so we have two parents. They are both heterozygous for eye color, and the rule still applies that brown alleles are dominant to blue alleles. So the first thing to do is that would be what the chromosomes look like. And obviously this is a big B and this is a little b. Big B, little b. After, and this would be the somatic cells, the body cells. How do I know that? The chromosomes are in pairs. Along comes meiosis and gives me the gametes. How do I know these are gametes? Because the chromosomes are in singles. The next step would be my Punnett square. So I take these two and put them here. I take these two and put them on the top. I have a big B and a big B. So if this sperm cell fertilizes this egg cell, I get big B, homozygous dominant. Because this option, the baby would inherit two alleles, dominant alleles from each, one from each parent. Number two, I have a big B and I have a little b. What would I get? I would get a heterozygous child because they have inherited two different alleles, one from each parent. Same goes with three. And the only reason this is just convention, it doesn't really make any difference to the final outcome. We always put the dominant allele first. So the capital letter always goes first. So I've got a big B and little b. Again, number three is heterozygous. However, if I have this gamete fertilizes this gamete, I end up with homozygous recessive. This is an option where the offspring inherits two alleles which are the same. That makes it homozygous, and they're both recessive, so homozygous recessive. So looking at my genotype chart, it should look like this, right? If you flipped everything around, it would be exactly the same. It would just be in the opposite order, but this is what it should look like. And the phenotype, so big B, that is going to be brown. Big B, little b, brown is dominant. You only need to inherit one dominant allele to have that characteristic. It's brown. Number three would be brown. And the only way you can have blue eyes is if you are homozygous recessive, so that's what the last one would be. So my question was, what is the chance of these two brown-eyed people having a blue-eyed child? Well, it's 1 in 4, right? 1 in 4, which equals a 25% chance of having blue eyes. There you go.